we covered example 13.1 in class. So that is about a cookie and ice cream shop determining the capacity requirement. So following that example, you can use this as an exercise question to reinforce your memory and about how to determine the capacity requirement. So this is some basic information about the problem. It is very similar to example 13.1. So the arrival rate is 30 customers per hour. On average, each customer will order one ice cream sundae, 12 cookies, and a 12-ounce and one 12-ounce self-serve soft drink. And each customer will spend about 30 minutes at a table. And a cookie sheet can accommodate a dozen of 12 cookies, and the baking time is 15 minutes. So on average, a server requires 5 minutes to process the order. So it basically takes about 5 minutes to take an order. So here we need to answer 3 questions. So the first question is facility requirement. So basically we want to figure out how many chairs we need to serve all the customers. So if you look at example 13.1, to answer this question, we are going to apply Little's law. So based on Little's law, L is a number of chairs required. It depends on 2 different things. One is lambda, a customer arrival rate. And second piece of information, it depends on how much time does each customer spend in the shop. So these are the 2 pieces of information we need in order to calculate the number of chairs we need. It's called Little's law. So if you read the question, we'll see the arrival rate is 30 customers per hour. So this is given information, 30 customers per hour. We also need to know what is the average time each customer will spend in the shop, which is W. So you can see W is about 30 minutes. Each customer will spend 30 minutes. So that the question is, don't use 30 minutes directly. The one key thing about using this formula to make sure lambda and W will have consistent time units. In this case, because lambda is 30 customers per hour, so it's a per hour. So in terms of time, W, we'll have to use hours. So 30 minutes, we have to convert to how many hours. So 30 minutes equal to 30 divided by 60 hour, which is half an hour. Then, so 30 divided by 60, half times 30, so get 15 chairs. So this is how many chairs we need to prepare in order to serve our customers. So by applying Little's law, we can estimate the number of chairs we need for a particular shop. Second question, we want to look at equipment requirement. How many cookie sheets we need? So first of all, we want to figure out how many cookies we need to make in 1 hour. So we have 30 customers per hour, so we'll have to serve 30 customers per hour. And each customer will order 12 cookies. So 30 customers per hour, that's how many customers we need to serve. Each customer order 12 cookies. So that's why 30 times 12. This is how many customers we have. This is how many cookies each customer will order. So 30 times 12, that gives us how many cookies we need to make in 1 hour. This is demand. 30 customers, each customer order 12. So this is total how many cookies we need to make. So the numerator, this term, the whole term, the numerator tells us how many cookies we need to make in each hour. We also have to look at the denominator. The denominator, we want to figure out how many cookies we can make with 1 cookie sheet. With 1 cookie sheet, how many cookies we can make. So if you read the information, it says a cookie sheet can accommodate a dozen cookies. So basically, every time you use a cookie sheet, you can make 12 cookies. It takes about 15 minutes. So I can make 12 cookies per sheet, but not in each hour. Because to make 1 batch of cookies, it only takes 15 minutes. Okay, it takes 15 minutes. So that means in 1 hour, each cookie sheet can be used 4 times. 4 cycles. Why? Because each time when we cook cookies, it takes only 15 minutes. So that means in 1 hour, one cookie sheet can be used 4 times. Okay, so 4 times. So 4 times, you can cook 4 times 4 cycles. Each cycle, you can cook a batch of 12 cookies. So 12 times 4, that gave us how many cookies we can make with 1 cookie sheet per hour. So numerator is that number of cookies we need to make in each hour. The denominator tells us how many cookies we can make per cookie sheet. So you do the math, get 7.5 and round it up, which is 8 sheets. That basically means we need 8 sheets. So whenever we get a fractional number, please make sure you round it up. So 7.5 we will round it up to 8. So that means we need about 8 sheets. The last one is about labor requirement. So basically we want to figure out how many people we need to hire to serve all the customers. So again, we're going to do a division. First of all, if you look at the numerator, we are going to serve 30 customers per hour. This is how many customers we need to serve in each hour. To serve those customers, each customer requires 5 minutes. It says a server requires 5 minutes to process order. That means a server has to spend 5 minutes to serve each customer. So I have 30 customers to serve, and each customer I need to spend 5 minutes. So 30 times 5, that tells us how much time I need to spend for all 30 customers. So that basically means how much service time I need to provide in each hour. So this number of customers times a service time per customer. So that is total time I need to provide to all the customers. And the denominator is just simply 60 minutes per hour. This is always 60 minutes per hour. For similar questions, we always use 60 minutes per hour. This tells us if we hire one person, this person maximum-wise can provide 60 minutes service time. Okay, so whoever we hire, maximize this person can provide 60 minutes per hour. Obviously, you cannot work more than 60 minutes per hour. So this is how much time we need to provide in total. This is how much time each server can provide. So you do the division, we get a number 2.5. This is how many servers we need to hire. Of course, you cannot hire 2.5 servers. In this case, we have to round it up. So we'll get 3 servers. So round it up. So that's how we complete that whole question, simply following example 13.1.